Hi grade 12s, welcome back to another one of our video lessons. So today we're going to continue on page 185. We're going to do the worked example. I'll show you how that particular example works. It deals with ratios of their different sides. And you guys are going to do exercise 4. We're then going to continue to surface areas of prisms and the worked example after that. And in the next lesson we're going to get into volume. All right, let's get into worked example. So it says a window pane has a ratio of height to width of 3 to 4. The total area of the pane is 156,000 millimeters squared. What are the height and width measurements? Okay, guys, I found the mistake in this worked example. It took me a while to figure it out, and their calculations are actually incorrect in the block on the right. So if you're looking on page 185, on the top right, there's a dotted red line that has the calculations that are pointing to the worked example. Now I'll tell you where the mistake is as we go through it. So let's first understand what is this ratio height to width they're talking about. So they say height to width is in the ratio of 3 to 4. Okay, so if my measurement is 1 centimeter, then my height is 3 centimeters, my width is 4 centimeters. If my common measurement is 2 centimeters, then my height is 6, my width is 8. Okay. If that common measurement is something else, it's still in the ratio of 3 to 4. Now, they've given us a particular surface area. That's not a guess, it's a particular 156,000 millimeters squared. So to get that particular surface area, we need a particular common ratio or common number that goes between both of these ratios. And that's that example that I was giving you. If it's 1 centimeter, it's this. If it's 2, it's that. If it's 5, it's that. Well, we don't know what that common part is. So we're going to call it x, okay? So let x be the common number between the two, and they're still in the ratio of 3 to 4. So what that gives us is that we draw a rectangle, and we know that the height is 3x, and the width is, the width is 4x. Okay. So whatever x is, we'll find out at the end of the example what particular x is to fit this particular setup to give us an area of 156,000. Okay. So given that ratio, now 3x and 4x, so in a similar example, all you're doing is you're putting an x in front of each one, and then you're using those as your sides in your calculation. Okay. So what is our area formula? Our area equals to length times width, okay, or height times width, or height and width. Okay, so let's use height and width. Okay, our area, they told us, was 156,000, okay, which equals to the height is 3x times the width is 4x. Okay, let's work that out. We're going to get 12x squared, so 156,000 equals 12x squared. Right, now we need to solve for that x, because once we find the x, we can then multiply 3 by x to get the height and 4 by x to get the width. Okay, so what we're going to do is we're going to divide by this 12 over here on both sides. So we divide by 12, divide by 12. Okay, that cancels with that, leaving us with x squared. So I'm just going to rub out on the top here. Okay, so that will leave us with the x squared, which would equal to 156,000 over 12. Now, the mistake is in the textbook. If you look in your book, they come up to the similar variation, right, of the solution, and then they get to the stage where they square root both sides, okay, and they get x to equal, and they say x equals 342.05 millimeters, okay, but that is incorrect. That is a mistake, guys. That is not the length of x. That is the length of the width okay, or rather the height that we are using. So it took me a while to spot that because I was using their number without doing my own calculation and it just wasn't working. So cross out that 342.05 millimeters and the answer there should be 114.02. Okay, that is what our x is. This is that common number that we are multiplying by 3 and by 4 to get our length, to get the very specific area that they gave us. Okay. Right, well, we haven't answered the question. Let's actually answer the question because they told us what is the width and height. Well, x is 114, therefore our height equals 3 times 114.02, and this now should equal 342.1 millimeters. Okay, remember our area was in millimeters squared, therefore height and length or width must be in millimeters both to give you millimeters squared. Right, so if height is that, our width is going to be 4 times 114.02, and that should give you that answer in the worked solution of 456.1. Okay. I'm hoping it's the correct workings. I mean, they seem to work. If we now multiply our width and height, these two, we will get 156,000, and you can check that. Okay. So guys, this is a very common question that gets asked in this type of section all the time. Okay, we are using ratios. There's an unknown factor x that you need to solve for, and then use that to find out your different length and width. Okay, so guys, I want you to use this example that I did on the board, worked example, and try to do exercise 4. Okay, now with exercise 4, it's a little bit confusing, but let me explain what they mean. So in number 1 says, alongside is a diagram from a manufacturer's window frame catalog. The catalog specifies that the total area of the window panes in the entire frame is 16,740 centimeters squared, and that the width of each pane is 2/3 the height. The width and height is in the ratio of 2 to 3. Okay. So there's your ratio. You know what to do with that, how to draw your height and width of your pane, right? The total surface area they gave you is of the entire window. But remember that entire big window is made up of like 1, 2, 3, 4, 5, 6 out of 24 little pieces of glass. So they're talking about the one piece of glass. So you can either work with the total surface area, or you can take the total surface area of 16,740 divided by 24 to get the surface area of one pane of glass, and then you're going to use the example above to pretty much solve that problem like we did just now. Okay. 1.2, what is the total length of beading required to secure all the panes into the frame? Okay, so the beading that they're talking about is the putty that they're going to put around the glass of each pane to put it into the wooden, frame. Okay, so what they're really asking here is that how much of that putty I'm going to need for each one of these panes to go around for the entire window. Okay, so you got to do that calculation and show me what you're calculating. Right, guys, number 2, you can try to figure it out yourself. It's pretty much the same as number 1, just a little bit of a different application. Okay, I'm going to continue. So what I want you to do is do exercise 4 and 5 for homework. I'm going to continue with surface areas of prisms on page 186. Okay. Right, so surface areas of prisms. So now we know how to find area. I can also ask you to find surface area of, let's say, a textbook, right? Your maths textbook, it has these dimensions. What is the total surface area of this book? Or I could say, here's a house, it has these rooms, these are the windows, I need to paint the walls in the house. How much paint am I going to need if 1 liter of paint covers 10 square meters? Okay, So you're not only working out area, you're actually thinking and applying yourself to the different applications of it and calculating what is the total surface area of something. You're dividing it by the consumption of paint, and you're telling me how much paint I'm going to need. So we'll get to those examples soon. Right, so let's talk about surface area of prisms. You have calculated the surface area of prisms before, particularly rectangular prisms, shapes like a brick, and cylinders. If a rectangular prism or cylinder is standing on one of its sides and all the upright sides are vertical, we then call this the side it is standing on the base. Okay, so the thing that the shape is standing on is the base of the shape. Okay, the area of all the surfaces is made up of the area of the top, which is the same as the area of the base, plus the area of the bottom, the area of the base, plus the area of all the vertical sides. You can get the areas of all the vertical sides by multiplying the perimeter of the base by the height. Okay, right, guys, so with these things, there's no exact formula to do it apart from the area and perimeter. You just have to look at your shape and make sure you account for each side of the shape. Okay, so remember our area, so our surface area, SA, of let's say a rectangle equals, okay, well let's say we have a rectangle over here, right? Actually, we're going to have a cube. Okay. Okay, we have a cube that looks like that, and our measurements is 2, 3, and 4. Okay, so width is 2, height is 3, and length is 4. Now I say to you, what is my total surface area here? Okay, well remember, the two surfaces at the front and at the back are the same. The two surfaces on the sides are the same, and top and bottom are the same. So in a rectangular prism or a cube, we have 6 sides that you need to take account of, and 3 of them are the same as the other side. So the front side is 3 by 2, right? That is our area. But we have 2 sides, so it's going to be 2 times 3 times 2. Okay, so 3 times 2 is that area there, times 2 of those sides. Plus, let's do this one. That's 4 times 3. So 2 times 4 times 3. Plus, so we've done that. Let's do the top. The top is 4 by 2. So it's 2 times 4 times 2, which equals 3 times 2 is 6. 6 times 2 is 12. Plus 4 times 3 is 12. Times 2 is 24. 4 times 2 is 8. Plus 2 times 2 is 16. Okay, then we add them all up. 24 plus 16 is 40, plus 12, 52, and let's say this was meters, then we would have meters squared. Okay, so guys, with rectangles, it's easy, just account for all the sides. Okay, right, let's continue. Then they say we can also have the surface area of a cylinder. Okay, how do we do that? Okay, so let's say we have a cylinder that looks like that. Okay, there's our cylinder. I'll do a dotted line here to show you the base. Right, so this is our cylinder. It has a radius R. Remember, with circles, the only important thing is the radius. And the cylinder has a height, which is H. Okay, so the surface areas is this top circle there, the bottom circle there, and we have this side over here. So if we take this can, roll it on a piece of paper, the contact that it makes is the surface area. So if we roll this thing out, it's going to be a piece like that. Okay. This side here is going to be H, which is the height of the can. What is this distance over here? Well, that's the circumference of the circle. Remember, it rolls out. So we need to know what is the circumference of the circle. The circumference of the circle is C, which is 2 pi r. 2 pi is just the constants, r is the radius of the circle, okay? So we would get that distance there, which is C equals 2 pi r. We have the height, okay? So now the surface area of the cylinder equals the two circles at the top. What is the area of the circle? It's pi r squared. So it's 2 times pi r squared, because that will be the two surface areas of the circles, plus the surface area of this, which is your 2 pi r times your height. Okay. And that is the formula for finding the area, surface area of a cylinder, guys. I suggest you learn this because you are going to need it, right? You need to know what the circumference is and how to work it out. And it's just C 2 pi r. R is the radius. And then you need to know that your surface area of a cylinder is this flat piece here that rolls out and the two pieces on the top. Okay, guys. So that is that. Let's look at worked example at the top. So it says a metal food can is 10 centimeters in diameter and 12 centimeters tall. What is its total surface area? Okay, so here we have a standard, example without any measurements. Now we're just applying certain radius to it. Okay. All right, so what we can do is we can work this out from scratch, or we can just fill in the values that they give us. So they say that the food can has 10 centimeter diameter. Okay, now this is a common trick. We don't use the diameter in these calculations. So you have to convert the diameter to radius and then do it. So if our diameter is 10 centimeters, then our radius is half of that, which is 5. So in this particular setup, our radius is 5 and our height is 12. Okay, that's the particular measurements they give us. Let's put centimeters here. Right, so what I'm going to do is I'm going to use the same setup. I'm going to go straight to this formula over here and fill in the values that I have. Okay, so obviously you guys can do it from scratch. I don't mind, but you can work these out separately and add them together, or you can go in one go. So this equals 2 pi r squared. So 2 pi r is now 5 squared. So all you're doing when you're substituting in a value, you put a brackets around it, put the value in, close brackets, done. Okay, so that's that, plus 2 pi r times h. So 2 pi r is 5 times h, which is 12. Okay, and that's that. Equals 5 squared is 25. 25 times 2 is going to be 50. So this is 50 pi plus 5 times 12 is 60. 60 times 2 is 120. So plus 120 pi. And that equals 270 pi centimeters. Okay, obviously I don't want to work out pi now. I don't have a calculator in my hand. But you guys are going to multiply 170 by pi in your calculator, which is 3.12. Yeah, and you'll get the answer. Okay. Now remember surface area, so we have centimeters squared. Okay. So what do they do here? They get 534 centimeters squared. Okay, let me find the calculator. Let's see if we get that. 170 times, just looking for pi. Yes, I get 534.07. So 534 is correct. Centimeters squared. Okay, cool, guys. So that is how we work out the surface area of a cylinder. Now, exercise 6 is going to look at page 182. So it's looking at the plan of the playground on page 182. And it's going to talk you through the different cylinders and shapes and stuff and working out areas. So guys, I want you to try exercise 6. So for this lesson, what we are doing, exercise 4, 5, and 6 is for homework. And we're going to continue with unit 3, which is volume, in the next lesson. Cool, thanks guys. I'll see you next time.